Hello everyone. Here we discuss the importance of a sinusoidal waveform in an electrical circuit. As you know, there are many alternating waveforms such as sinusoidal waveform, triangular waveform, square waveforms and other waveforms. But the sinusoidal waveforms used in electrical system because it has a natural form of AC generation. As you know, that sinusoidal waveform we can generate by moving a coil in a fixed magnetic field, or you can say by moving a field in a fixed coil. So, in both the ways, we can generate our alternating waveform. That alternating waveforms comes in a form of sinusoidal waveform, and this kind of generation we can be used in generators, AC generators, and they can be transmit in a wide range. On the other side, if you analyze other alternating waveforms such as square waveform, it is generated by a function generator or a digital switching circuit where we switch a transistor or logic gates rapidly to form our square waveforms. And if you analyze the triangular waveform, it is a integration of square waveform, so it can be generated by an integrator circuit with the input of a square waveform such as RC integrators. So the sinusoidal waveform is a natural form of AC generation because we got the electricity from the natural resources. So it is a basic uh, waveform to produce an electrical energy. This sinusoidal waveform also gives the mathematical simplicity in an electrical circuit. As you know, the electrical system consists of linear elements, and the voltage across their linear elements such as inductor, that is defined as LdI by dt, inductor voltage, and if you analyze the capacitor voltage Vc, that is 1 upon C integration of I dt. It means it gives the differentiation of sinusoidal waveform and integration of sinusoidal waveform current. So it will provide the same nature of current, that means the same frequency current, but it a shifted waveform. So you can easily add or subtract that waveform's value with their phasor representation. So it is provided that they give the mathematical simplifications in an electrical circuit. Next point is these waveforms are efficient for power transmission. They are ideal for power generation, transmission, and distribution. And these alternating currents, that are sinusoidal currents, provide minimum losses and interference in a network. The sinusoidal waveform provide smooth variation in amplitude, as the square waveform provide a sharp transition in the amplitude magnitude, and this triangular waveform also provide a linear ramp up, or as you can say a linear ramp down in the magnitude. So for this smooth operation of magnitude in the sinusoidal waveforms, they provide a smooth torque in a motor, and they also provide a stable operation for transformers and generators. A sinusoidal voltage or current wave consists of fundamental frequency, so they avoid unwanted harmonics that produces by distortion or heating in a system. You can see some harmonics in a system if you apply a nonlinear node or by some other means. That harmonics can be analyzed by Fourier series representation, but uh, these harmonics can be suppressed by some other methods, and these sinusoidal waveforms having less harmonics in comparison of other types of alternating waveforms. That's why this is widely used in electrical systems. The sinusoidal voltages and currents are compatible with the AC equipment, as most of the electrical devices such as motors, alternators and transformers, they are designed to operate efficiently with this sinusoidal waveform. As we discuss the sinusoidal waveform importance in an electrical circuit, now we analyze the alternating waveforms and their applications and their key characteristics. First, analyze this sinusoidal wave that gives the power generation, transmission, distribution, and they are used for AC motors and transformers. Their characteristic is it has smooth, continuous variation, provides minimum harmonics, and they are efficient for energy transfer. If you analyze the square waveform that is widely used in digital electronics and clock signals and switching the circuits, and it characteristic has it has a sharp transition and high harmonic contents, so it is used for logic and timing. And if you analyze this triangular wave, it is widely used for signal testing, modulations, and waveform generators that provide other types of waveforms. And its characteristic is it has a linear rise and fall, so it provides some moderate harmonics and used for ramp and control the signal. Thank you for watching the concept. Please like and subscribe my channel.